Department of Collegiate and Technical Education welcomes you to Learning and Management System program first year BE common to all course Engineering Physics course code 18 PHY 12 bar 22 module 4 laser sport session 2 learning outcomes. At the end of this session, students are able to understand requisites of a laser system, conditions for laser action, and some possible questions. Requisites of a laser system, as we know, in the construction of any laser, it requires mainly three components, which are laser cavity, active media, and excitation source. Laser cavity, it is a compartment used to place the active medium. It consists of a quartz discharge tube. One of its end is pitted with partially silvered mirror through which the laser beam will come out after reaching threshold limit, whereas the other end is pitted with fully silvered mirror, which is used to enhance photon density in the active medium through multiple reflections. The cavity also provided electrical contacts to produce electric discharge in the gaseous mixture. Active medium. It is a medium composed by atoms or molecules where the lasing action takes place, like population inversion and amplification of light and stimulated emissions. Examples for active medium. The active medium is different for different lasers. If we go for solid laser, ruby laser, aluminum and chromium elements are the active medium. When we go with helium neon laser, helium and neon molecules are the active media. When we go with semiconductor laser, gallium and arsenide is the active medium. When we go with carbon dioxide laser, CO2, N2, that is nitrogen, and helium atom forms the active media in the carbon dioxide laser. Third one, excitation source. It is the external agency used to pump the atoms to higher energy level in the active medium. Examples. Here also the mode of excitation source or excitation mechanism is different for different kinds of laser. When we go with semiconductor laser, forward bias is the excitation source, whereas when we go with ruby laser, xenon flash lamp is the excitation source. When we go with gaseous lasers such as helium neon, carbon dioxide, in which the electric discharge is used to excite the atoms to higher energy level. Therefore, the excitation source is different for different types of lasers. Principle and conditions for laser action. The laser beam generates only with the following conditions. The laser beam, the main consequence is stimulated emission. That means the excited atom falls back into the ground state with the assistance of another photon of right energy by emitting two identical photons with same phase. This is we call stimulated emission. As we know that under normal thermal equilibrium conditions, at a normal conditions, there will be less number of atoms in the excited level, whereas more number of atoms may be in the ground level or lower energy level, since the atoms may not get enough energy to go per higher energy level under normal conditions. But for getting more number of stimulated emissions, we need more number of atoms to be in excited state. Excited state. So as I said, as we discussed earlier, under normal conditions, majority of atoms remains in ground state, whereas only few number of atoms will be there in excited level. When the light of suitable energy is incident on the system, more number of absorption dominates than that of stimulated emission. Therefore, to get more number of stimulated emissions, we need more number of atoms to be in excited state. So how to achieve or how to get more number of atoms in excited state, that we discuss here. So you can observe in this figure E1, E2 and E3 are the energy level. When we lift the atoms from E1 to E3 by giving energy of photons, which is equal to E1 minus E3 is equal to h nu, when the atoms are excited to E3, since E3 is highly unstable, the atoms does not spend long time. It spends about 10 to the power of minus 9 seconds and immediately decays to ground level. Suppose if there is any energy level in between the highest and ground level, this energy level acts as intermediate energy level. That means the lifetime, average lifetime of the atoms in this energy level is relatively more than highest energy level. That means here the average lifetime of the atom is 10 to the power of minus 3 second, whereas in the higher energy level the average lifetime of the atom is about 10 to the power of minus 9 second. The time difference between the highest and metastable state is 10 to the power of plus 6 times. This is very high. Therefore, the number of atoms, so the number of atoms whose lifetime will increase in the energy level say E2. Now we study what is meant by metastable states or the special kind of excited states in which the lifetime of the atoms is about few milliseconds. As I mentioned earlier, this is 1 million times more than the lifetime of normal excited state. Therefore, the population inversion can be achieved in these states. Population inversion is nothing but the number of atoms in the excited state is more than number of atoms present in the ground state. This is artificial condition. This is against to natural population. Usually, more number of atoms will be in ground state, whereas very less number of atoms will be in excited state. So, as I mentioned here, the atoms are lifted from even to E3, then it decays to E1 through E2 since the lifetime of the atoms in the E2 energy level is relatively more, therefore, more number of atoms gathers in this energy level. Therefore, the number of atoms is in E2 is more than number of atoms in E1. Therefore, this kind of situation we call it as population inversion. This kind of situation we call it as population inversion. This is a special kind of environment in which the number of atoms in the excited state more than number of atoms in the ground state. One can observe here the number of atoms in N2 level is more than number of atoms in the N1 level. Here, if any one of the atom decays spontaneously to ground state, that spontaneous photon will have suitable energy to trigger remaining atoms present in the same excited level. Therefore, all the remaining atoms will decay to ground state through stimulated emission. Therefore, the laser action takes place. Here, you can take a note, this could be achieved by optical pumping mechanism in the case of ruby laser. The population inversion can be achieved in the case of solid state laser, that is gallium arsenide laser, by forward bias. In the case of gaseous laser, one can achieve through electric discharge. These are the possible questions. Define resonant cavity. As I mentioned earlier, it is a compartment used to place the active media. Second, define active medium. It is a medium composed by atoms or molecules where the laser action takes place. Define excitation source. It is an external agency or outside energy which is used to lift the atoms from lower energy to higher energy level in order to achieve population inversion. Why the one end of the cavity is pitted with the pulley silvered mirror? Already I mentioned it is used to enhance photon density. That means to get amplified output in the laser through multiple reflections. Why are the metastable states are required? Just now we studied without metastable states, no population inversion is observed in the active medium. What is the condition for stimulated emission? There are two conditions for stimulated emission. One is the atom must be initially in excited level, and another condition is the photon must interact with excited atoms. What is the population inversion? It is the special kind of situation in which number of atoms in the excited level more than number of atoms in the ground state. What is the lifetime of an atom in the excited state? It is about 10 to the power of minus 9 second. It is very small. It is due to highly unstable. What is the lifetime of an atom in the metastable state? It is 10 to the power of minus 3 second. It is relatively larger, which is mainly used to achieve population inversion in the active media. Why the population inversion takes place only in metastable state? Just now I mentioned, since the lifetime of the atom in metastable state is more, therefore population inversion achieves. These are the content developers. Thank you.